Hi guys, I'm back with another video, this time for week 3, and again the assignment 2 where you are looking at SPSS output. So this week your assignment is looking at folks who attended or did not attend a company event and their job satisfaction. But I'm going to show you a different data set again, but using the same kind of t-test so you can look at what's going on. So first, the research question. So we just talked a little bit about that. Remember your variable name and your variable names are not the same as the two levels of that variable. So attend and did not attend are levels of one particular variable. The second is hypothesis. So this is a little bit new this week, and you'll read in your book about null hypothesis and alternative hypothesis. And this gets a little tricky, but the null hypothesis is always that there is no relationship in the population. That's always what you're testing with statistics, that there is no relationship. So in order to do that, to write these, I'm going to pull up a Word document here. So the null is no relationship. So if that's the case, that would indicate that the mean of job satisfaction, so I'm going to type that in, the mean of job satisfaction for the attended group would equal the mean of job satisfaction for the did not attend group. Now, in statistical notation, the mean of job satisfaction is indicated by the mu symbol. And if you're in Word and you go to Insert up at the top and you go over to the symbols on the right, for me the symbol at the mu is right here. If it doesn't appear right there, you can click on More Symbols and find it. So we'll go mu, and then we'll have for the attended group. So this means mean of job satisfaction for attended equals, we'll get our mu back again. Oh, it moved since I just used it, for not attended. And we can actually make these into little subscripts. If we go back to home and click on subscript for the mean and the mean of the not attended group. And so that's going to be our null. Null is always that they are equal, because if those two means are equal, it means there's no relationship between those variables. On the other hand, if there is a relationship, those means would not be equal. And again, we can find a not equal sign in that same symbol place and put that there. So that would be the scientific notation for the hypothesis. Remember, always the mean, or the null hypothesis is no relationship, which means the means will be equal. I know that's confusing. I hope that makes sense for you. All right, so the next piece, the variables. So again, you should be getting used to thinking about the variables. And the descriptive statistics you're going to find just like we looked at descriptive statistics last week. So your mean, your median, your mode, and your variability, and then you're going to look at that shape of the distribution. So let's move down to the t-test. So remember, there's different kinds of t-tests. One t-test is independent samples, and that's if your two groups, attended and not attended, are different people. A paired samples t-test, or repeated measures, those are the same thing, are run when you have the same variable tested on the same people. So it's maybe group at time 1 and group at time 2, and it's the same people at time 1 and time 2. That would be independent samples. In this case, we have the groups are separate people. The people who attended is one group, the people who didn't attend is another. So in my output here, I'm going to look at this and say, and this study looks at whether two levels of stress, low stress versus high stress, consume different levels of caffeine. So when I go down and look at my t-test results, I see two different groups here, two different tables, and just as you will in yours. The first table tells me the low group had an average caffeine consumption of 9.58 drinks. The high group had an average caffeine consumption of 11.08 drinks. So remember, this is just in my sample. So I can look in my sample and say, well, the high group had more, they drank more. But the question is this difference significant in the population? And remember, that's why we run the t-tests. So that's what the next table tells us. Now, there's a couple of things to look at here. First, this first section is not your t-test, even though there's a significance value here. This is actually looking to see if the standard deviations are fairly equal to each other. That's one of the assumptions statistically that we have to meet of a t-test. I'll just say in this class we're always going to use this top row, and this significance number is going to be high enough that we don't need to worry about it. So look at the top row here, and here's our t-test, the results of our t-test. So the value of t that we get is negative 0.93. Remember, we're going to report to 2 decimal places. And the significance is 0.36. So remember from last week, we're always looking at, does that significance number, that p-value, is it greater than or less than 0.05? And that's our probability of the null being true. So last week I didn't get into the null, but it's the probability that there's no relationship. So in this case, p is greater than 0.05. So that means the probability that there's no relationship is pretty high. So we do not say there is a significant, in this case, there is not a significant difference between our two groups because p is greater than 0.05. So if p had been less than 0.05, we would say there was a significant difference between these two groups. So this is, again, always looking at this significance number. Is it greater than or less than 0.05? So even though we have about a 1.5 drink difference here between low and high group, because we've got a fairly small sample and because this difference isn't that big, it's not likely that there's a big difference in the population. So in this case, we fail to reject our null. So remember, our null is that the two groups are equal. We found out the probability of this being true is 0.36. So that's a pretty high probability, so we can't reject that. I know that gets confusing. Let me try to say it one more time. The t-test is testing how likely it is that these two means are equal. We found out the probability that they're equal is 0.36. Since that is greater than 0.05, we say it is likely they're equal, so there is not a significant difference between the means and the population. There is not a relationship between stress and how much caffeine you've consumed. So that's how we look at the output of a t-test and think about what those results mean. And when you look at your questions then, that's what it's going to tell you about your hypothesis. Let me talk one more thing about a one-tailed or a two-tailed test. One-tailed is going to be if your hypothesis is that your alternative hypothesis is that one group is higher than the other group. That's just one direction. You'll run a one-tailed test. In this case, we were interested just in whether the two groups were different. One could be higher or lower. So that's two directions. That's going to be a two-tailed test. So the key is to look in here and figure out if you're looking at just is satisfaction different, in which case it could be higher or lower, and you would run a two-tailed test. So that's what you're going to be looking at. And you can also tell right here it says two-tailed. That's going to tell you which one was run for your particular test. So you're going to look in your output and figure out which one of those was run to be a one-tailed or a two-tailed test. All right, so I hope that helps. And again, please ask if you have any questions. Thanks.